In this lesson, we're diving deep into the fascinating world of hydraulic systems. Let's start by breaking down the essential components that make up a hydraulic circuit. At the heart of any hydraulic system, you'll find the hydraulic pump, which is often misunderstood. Many people think that pumps create pressure, but that's not quite accurate. Instead, pumps generate flow, and it's the resistance to that flow that creates pressure within the system. So what exactly creates pressure in a hydraulic system? It's actually the load that the system is working against. When the hydraulic fluid encounters resistance, that's when pressure builds up. This is a crucial distinction to understand, especially when we consider how hydraulic systems operate under different conditions. Now, let's talk about the working pressure in hydraulic systems. Unlike pneumatic systems, where we often see pressures around 4 to 5 bars, hydraulic systems typically operate at much higher pressures. Depending on the application, hydraulic systems can function anywhere from 70 to over 300 bars. This high pressure is what allows hydraulic systems to perform heavy lifting and precise movements. Next, we have the hydraulic actuator, which is responsible for converting hydraulic energy into mechanical energy. This is where the magic happens. Actuators can be cylinders or motors, and they work by using the pressurized fluid to create motion. Understanding how these components interact is key to mastering hydraulic design. Another important aspect is the hydraulic fluid itself. It's not just any liquid, it needs to have specific properties to ensure efficient operation. The fluid must be incompressible, have a high viscosity index, and provide lubrication to the moving parts. This is why selecting the right hydraulic fluid is critical for the longevity and performance of the system. Let's also touch on hydraulic valves. These components control the flow and direction of the hydraulic fluid. They can be manual or automatic, and they play a vital role in regulating the system's performance. Understanding how to select and configure these valves is essential for designing an effective hydraulic circuit. As we explore these components, it's important to remember the common misconceptions surrounding hydraulics. For instance, many believe that the larger the pump, the better the performance. However, it's not just about size. It's about matching the pump to the system's requirements. An oversized pump can lead to inefficiencies and increased wear on components. In summary, the hydraulic system is a complex interplay of components working together to create powerful and precise movements. By understanding how each part functions and interacts, you'll be well on your way to mastering hydraulic system design. This foundational knowledge will serve you well as you continue to explore the intricacies of hydraulics.